2.2 Problem Solving Strategy. In these sections, we will review the word problems that we learned in elementary algebra. We specifically going to look at three types of problem in these sections: direct translation problem, consecutive integer problems, and investment problem. I would like you to do a full-step format for all the word problems for this course. Step one will be you assigning the variable to the unknown quantities in the problem, which you need to read the questions carefully and analyze it. And after that, step two, you're going to be setting up the equation, and step three, solving it. Finally, whatever the result you got, you need to interpret it for the problem. So let's take a look at on direct translation problem. So this type of problem give you enough information to set it up the equations. So you don't need to use formulas or anything like that. Okay. So example 1, Gilmore bought textbooks and notebooks at the bookstore. The numbers of textbook was 3 more than twice the numbers of notebooks. He bought 7 textbooks. How many notebooks did he buy? So in this case, we don't really know how many textbooks or how many notebooks he bought. So my first step will be assigning the variable. So the numbers of textbook and the numbers of notebooks. Now the question is which ones you want to assign the variable to. Now, this problem, there is a relation between two unknown quantities. It said that the numbers of textbooks is 3 more than twice the numbers of notebook. So you need to know the numbers of notebook first in order to talk about how many textbook do we have. So we will say that the notebook will be x, and the textbook is 2 times x plus 3. Now, using these unknowns, we can set it up the equations. The statement that allows you to equate is this. He bought a total of 7 textbooks. So that means 2x plus 3 must be equal to 7. And finally, we want to solve for it. So subtracting 3 on both sides, solving linear equations, right? So that will be 4. Dividing 2 to both sides, that will be 2. So finally, I need to interpret my solution, because what you solve for may not be what the question is asking. So in this case, the question is asking how many notebooks did he buy? So the notebooks is represented by the variable x. So now I can tell that he bought 2 notebooks. Example 2. According to the National Automobile Dealers Association, the average cost of a car in 2014 was $28,400. This was $1,600 less than 6 times the cost in 1975. What was the average cost of a car in 1975? So what we don't know in this problem is the cost of a car, average cost of a car in 1975. So my unknown will be this, the average cost of a car in 1975. So we let that become x. second, you're going to set it up equation. Now this statement tells you the cost in 2014 and the cost in 1975, the relation between them. So 2014, the cost is 28,400, and it said that this was 1,600 less than 6 times the cost in 1975. So 6 times the cost in 1975, and then 1,600 less. So that will be our setup equation. So now, from here, we can basically solve the linear equation, which is add 1,600 to both sides. That will become 30,000. Then you divide by 6 to both sides, which will become 5,000. Now we can interpret it what the question is looking for, which is the average cost of car in 1975. That will be 5,000. So we interpreted average cost of a car in 1975, which is represented by x, and we know the value of x is 5,000, so therefore 5,000 is my final answer. Next topic is reviewing the consecutive integers problem. So these are the phrases that you need to know and how they works. Right? So 3 consecutive integers, that means like 5, 6, 7, one after another. So if you talk about 5, 6, 7, then each only have 1 unit apart, right? 1 unit apart. So therefore, you can say that the very first number to be n, and the next number will be n plus 1, and the next number will be n plus 2. So you add it up one by one. So same thing if you talk about consecutive odd integers. So what would you do is like you would start with an odd number and then continue the next odd number, which is 11, 13, 15. And as you can notice that 11 to 13 is 2 units apart, 13 to 15 is 2 units apart. So when you represent algebraically, the very first odd number will be n. The second odd number, instead of adding 1, now you have to add 2. So therefore, n plus 2. And the next number will be n plus 4 because you add 2 more to the second one. Similarly for the even consecutive integers. So these are algebraic expressions that you want to, understand so that it's easier to translate. So let's take a look at on example number 3. 3 times the largest of 3 consecutive integers is 10 more than the sum of the other 2 integers. Find the middle integers. So in this case, first my unknown will be 3 consecutive integers, which we don't know. So step 1, I will say that first integer, and usually we will always assume that the first integer will be the smallest one, and then the next one, and then the next one. So therefore, the very first one will be x. Since it's consecutive integer, they have 1 unit apart from the first one to the second one, so it will be x plus 1 for the second, and then x plus 2 for the third because there's 1 more than the second. Now we will use these variable expressions to translate. Now it said that 3 times the largest, so the largest and 3 times, so 3 times the largest will be what? X plus 2 is, that means equal to 10 more than the sum of the other two. The sum means what? Additions. So the first integer plus the second integer, that's the sum of the other two. And then we have what? 10 more. So that will be our equation setup. Now, we're going to solve this, solving linear equations distributed first on the left-hand side. That will give me 3x plus 6 equal to, on the right-hand side, simplify inside the parentheses, inside the brackets, and that will be 2x plus 1 2x plus 1 plus 10. Now, we try to simplify everything, so it'll be 2x. 1 plus 10 will be 11. Solving linear equations, subtract 2x to both sides. That will become x plus 6 is equal to 11. And then subtract 6 to both sides. So therefore, I got x is equal to 5. Now interpreting. Now, the question is asking for what is the middle integers. But x representing the very first one. So if you want the middle one, we need to substitute the value of x into the second integers. So now we know that our middle integers is 5 plus 1, which is 6. That will be our interpretation. So it is very important that you follow strictly these 4-step strategy. Example 4. Find two consecutive even integers such that 3 times the first is 8 more than twice the second. So in this case, what we don't know is two consecutive even integers. This is very important, even. So when I assign the variable, I should specifically say that first even integers, because earlier in the chart we already noticed that the even consecutive integers and odd consecutive integers has the same algebraic expression. So it is very important that you indicate the first number is even or the first number is odd. So now I have the second even integer. So by saying that, I know that my first one is x, and the even integers are 2 units apart from one another. So it will be x plus 2. Now, setting up equation. It said that 3 times the first, so that means 3x, is equal to 8 more than twice the second. So twice the second number, and then 8 more. So now, to solve this, I have to distribute it on the right-hand side. So this will be 2x plus 4 plus 8. Simplify further on the right-hand side, which is 2x plus 12. Now, isolating the variable by subtracting 2x on both sides, that will give me x is equal to 12. That is our step 3. Finally, my step 4, interpreting. This time they want both of the answer. So the variable x is representing the first even integer. So I will say that first even integer is 12, and the second even integer is 12 plus 2, which will be 14. And that will be our final answer. The next topic is reviewing this investment problem. Simple interest problems have a formula, which is simple interest is equal to principal time interest rate time the time. Once we go into chapter 10 or 11, chapter 10, we will have a different interest formula, right, using the exponentials to compute it. So let's review on this simple interest formula first. So simple interest formula is simple interest earned equal to principal time interest rate time the time. So the first problem is said that an investor has a total of 10,000 deposited into two simple interest accounts. On one account, the annual simple interest rate is 7%. On the other account, the annual simple interest rate is 8%. How much should be invested in each account so that the total annual interest earned is 785? So this keyword, simple interest, help us to consider using this formula. And in the future, later in a later chapter, I will point out what keywords we need to pay attention to. Okay. So in this case, since whenever we have a formula, I would like to organize with the chart, which make it a little bit much clearer and easier for us to organize. Okay. So the chart basically is writing the formula out. Principal, time, the interest rate times the time is equal to interest earned. And in this case, we have two accounts, right? What we don't know is we don't know how much we put it into each account. That's the principal. Right? How much we invested, we don't know. So I would say that the first account is 7%. We can say that account 1, and the second account is giving you 8% interest, which is account 2. Now, let's fill in something that we know first. The first account, the interest rate is simple interest rate is 7%, so that means it's 0.07. That's the interest rate. And the second account, the simple interest rate is 8%, so we put it sign 0.8. Now you need to convert it into decimal, okay? And the the principal, it said that the total investment is 10,000. So I need to know how to split it into two accounts. Now, for example, if you have $10, that's total, and you split it into two. If I give one of them is $4, and the other one will be 6. How do I get 6? It's total minus the part of it that I give it away. So therefore, I can say that either account has X amount of dollar invested, and the other account must be the total that you have, which is 10,000, minus how much you invested into the first account. So that will be 10,000 minus X. The time, it said that the total annual interest earned, so we know that annual means only one. That give us this. And we are interested in this annual interest earned that will be equal to $785. So we need to know the interest earned from the first account and the interest earned from the second account. So that basically easily can be obtained by using the formula on the top. So the interest rate times the principal times the time, that gives me the interest earned, and interest rate times the principal times the time, right? That gives me the interest earned. And we know that these two interest earned amounts added up to be 785. So that will help us to get our equations. Okay, so let's continue on the second step, writing the equations. So that will be 0.07x, the interest earned from the first account, plus 0. Oh, I made a mistake right here. That should be 8. Okay, 0.08 times with 10,000 minus x. That will be equal to 785. So solving this, first distributing 0.08 into both of the term, that will give me 800 minus 0.08x equal to 785. Simplifying further on the left hand side, which is 0.07x minus 0.08, that will give me negative 0.01x is equal to 785. Subtracting 800 to both sides, that give us negative 15. Okay, and dividing both sides by negative 0.01, that give me x is equal to negative and negative become positive, so it will become 1500. So now we can interpret the last step, which is asking you how much should be invested into each account. So x representing the account that gets 7% interest rate, so we say that 1500 invested in 7% account, and the remaining, which is going to be what, 10,000 minus 1500, that will be 8,500 invested in 8% account. So that will be our final answer. Next example 6. The total of 7,000 is invested into two simple interest accounts. It's very similar to the last one, right? One account, the annual simple interest rate is 7.5%. On the other account, on the second account, the simple the annual simple interest rate is 10%. How much should be invested in each account so that the annual interest earned by each account is the same? So similarly, like in previous problem, we notice that simple interest rate, so that tells us which formula to use. Okay, so principal time rate times the time is equal to the interest earned. So the first account is 7.5% interest, and the second account is 10% interest. So as usual, we're gonna fill in, the information. The rate is 7.5%, so it'll be 0.075 for the first account. 10% on the second account, so it'll be 0.10. And again, same thing. We are interested in talking about annual interest, so the time is 1 year each. Now, going back to principal. Okay, I have a total of 7,000. So like in previous example, I can say that one of account will be X amount that I invested, and the other account must be whatever left over from the 7,000, so it will be 7,000 minus X. So now, if I multiply all of these, 0.075x, that gives me the interest earned from the first account, and 0.10 times 7,000 minus x, that's give me the interest earned from the second account. Now, the difference between this problem and this previous problem is this. And the last statement is that how much should be invested in each account so that the annual interest earned by each account is the same. Okay, it doesn't give you the amount combined together like in previous example. It tells you the interest earned from each account is the same, meaning they must be equal to each other. So now I can say that 0.075x must be equal to 0.10 times 7,000 minus x. Distributing on the right hand side, that gives me 700 minus 0.10x. Adding 0.10 to both sides, that will give me 0.10 175x is equal to 700. And dividing both sides by 0.175, okay? And remember, you can use calculator, so there's no point of no point of, like, dividing using the long division in this case. So when you use a calculator and divide it, that will give me my x is equal to 4,000. Now we can interpret it, which is the x is representing for a 7.5% interest account. So 4,000 invested in 7.5% account, and then 7,000 minus 4,000 will be 3,000 invested in 10% account. So this will be the end of 2.2.